Hello, friend. I'm glad you're here in this small pocket of quiet. The room is dim, the air unhurried, and your breath moves like a tide that knows the shore by heart. Nothing to fix, nothing to chase, just a soft voice and the steady comfort of being held by the night. Tonight, we'll press a luminous question beneath the pillow. What truly happens when galaxies collide? Not a crash, but a decades of billions, year-waltz stars, slipping past stars, tidal arms unfurling like silk, and dark halos weaving a slow embrace. We'll wander gently through those grand encounters, listening for the hush between bursts of new starlight, and imagining how worlds tucked inside might feel the passing of a cosmic neighbor. If this kind of quiet learning helps you rest, a light tap on like and a soft subscribe whenever it feels natural helps others find this calm. For now, let your shoulders settle, let your thoughts loosen, and let the night carry you the way gravity carries whole cities of stars. Close your eyes. The universe is dimming the lights, and we'll begin together, slowly, warmly, here. Collisions in space sound like thunder, yet the truth moves at the speed of patience. What happens when galaxies meet is closer to a slow waltz than a crash, a steady drawing together by gravity's quiet hand. These vast cities of stars aren't nailed to the sky. They travel, tugged by invisible threads, leaning toward one another across gulfs of darkness. When they finally touch, the meeting takes hundreds of millions of years, sometimes billions, a kind of drifting embrace that reshapes them without hurry. From a distance, the steps are simple. The outskirts feel the pull first. Tidal fingers reach out, teasing long streams of stars into space like silk being unspooled. Gas clouds feel the squeeze and kindle fresh clusters of newborn suns. The great disks tilt and warp. In time, two centers circle closer, like lanterns spiraling down a staircase. Much later, the cores settle into one, and a new galaxy breathes in the afterglow. Nothing about it is sudden. The spectacle is grand, but the tempo is soft. It helps to remember what a galaxy is, not a single object, but a neighborhood with its own weather. Stars, gas, dust, and something unseen moving together under gravity's care. Picture a city at night from far above, every window a point of light. Streets and districts appear as patterns, not because anyone drew them, but because the whole has a rhythm. A galaxy holds that same kind of pattern, only the blocks are measured in light years, and the avenues are rivers of orbiting stars. Our home, the Milky Way, is a barred spiral with somewhere between 2 and 400 billion suns. Many carry planets. On some of those worlds, oceans lift and fall, winds comb the ground, and maybe songs have been sung. Even with all that life and motion, the whole system circles its center like a calm wheel. The wheel holds together because space itself yields to mass. Gravity is the architect that never raises its voice. It bends the fabric of reality just enough that stars keep company instead of fleeing. Yet the luminous parts, the glittering spirals, the glowing nebulae do not tell the whole story. Around every bright disk is an invisible halo, an enormous cocoon made of dark matter. It neither shines nor swallows light. It simply weighs. By that weight alone, it reveals itself. Without this hidden scaffolding, a spinning galaxy would fling its stars away like sparks. Astronomers add up the motion and find that most of a galaxy's mass is dark. Roughly 85% of what gathers matter into form. Think of the visible galaxy as a lantern, and the dark halo as the great unseen balloon around it that holds the lantern steady in the wind. Shapes say a lot about history. Spirals show their youth in blue-white star nurseries, tracing graceful arms. Those arms are not rigid. They are waves of slightly higher density, like slow traffic that bunches up and then releases, coaxing gas to collapse and ignite. Our Milky Way wears a central bar, an elongated spine of stars that feeds material inward and stirs the disk. Ellipticals look smoother, rounder, often golden. Their stars older and quieter, their gas mostly used up or heated beyond easy collapse. Many giants in the universe carry this elliptical calm, as if they've already lived through the fiery adolescence of collisions and settled into senior posture. Irregulars refuse categories. They are the scuffed sneakers of the cosmos bent, asymmetrical, sometimes unruly, often shaped by past encounters that left them delightfully off balance. Size ranges widely. Some galaxies host trillions of stars. Many are dwarfs, with only a few billion. Dwarfs are common, like cottages scattered at the edges of a metropolis. The Milky Way has a small retinue of these companions, including the large and small Magellanic Clouds, faintly visible from southern skies as soft patches. Over long spans of time, several companions fall inward, their stars braided into our halo, proof that galaxies live in communities where neighbors are sometimes gathered in. Stillness is an illusion here. Stars orbit the center. Gas drifts and clumps. Spiral arms ripple. Bars turn like slow screws. Star nurseries flare to life and burn out. Supernovas scatter heavy elements the way dandelions scatter seeds. The galaxy you see tonight is already different from the one photographed 100 million years ago, and the one to come will wear that difference without apology. These are living systems, working on a clock too large for human habit. Despite the grandeur, a galaxy's shape is delicate. It exists because gravity, rotation, and mass have reached a careful truce. Disturb the balance and the figure changes. Encounters pull out streams like bridges of starlight. Tidal tails draw elaborate curves across nothingness. Bars lengthen. Disks puff up or melt into rounder forms. Resilience shows up in survival. Even after the most dramatic meetings, a new, well-proportioned galaxy emerges from the debris, as if the universe insists on harmony after every storm. Not so long ago, those faint smudges were a mystery. Some thought they were little clouds within our own Milky Way. The debate ended when careful measurements showed they were far beyond, each a separate island universe strewn across space. With better telescopes, the count swelled beyond imagining. Not millions, not billions, but likely trillions, scattered through the part of the cosmos we can see. The night sky on Earth offers only a handful to the naked eye, yet the darkness is thick with them, each a story unfolding on a scale that makes human history feel like a held breath. Home matters. The Milky Way spans about 100,000 light-years from side to side, a silver river when seen from the countryside as a pale band. Deep at the center hides a supermassive black hole, a gravitational well around which the inner stars sweep. It does not act like a vacuum cleaner. It acts like an anchor. The whole disk turns in a calm, stately spin, set by the mass of everything within, visible and dark together. We live near the edge of one spiral arm, tucked in a quiet neighborhood where the night is usually uneventful. Galaxies do not prefer solitude. They gather in groups and clusters, following the deeper locations of the cosmic web, the vast, three-dimensional network of dark matter filaments. Along those threads, Galaxies are the fireflies, and between them lie wide, dim voids. Gravity pulls along the filaments. Dark matter holds the lanes open. The luminous structures trace routes that were sketched in the universe's earliest moments. From the right vantage, everything looks like lace. Motion is not an accident, but an inheritance. The early universe had gentle ripples in density. Matter fell toward the slight highs, not in straight plunges, but along curved paths, acquiring spin. That original momentum never disappeared. Add the tug of neighbors and you get wondering. Even our own Milky Way moves with purpose, drifting through space toward Andromeda. The speed sounds like a dare, hundreds of thousands of miles per hour, yet the distance makes haste irrelevant. The meeting waits about 4 billion years in the future. Long before that, other small companions will arrive, and long after, the merged remnant will glow with a different profile, its stars relabeled by new orbits, its history gently rewritten. Encounters are where the quiet becomes visible. When galaxies pass close, the outer stars feel unequal pulls. That difference stretches the shapes, carving long tails and bridges. Gas clouds are compressed, sparking waves of starbirth that sweep across the colliding disks like slow rain washing over a field. Meanwhile, the great dark halos flow through one another, almost without friction, like two vast, invisible balloons overlapping. The halo's size and shape help decide how the final galaxy will look, whether it keeps some spin or relaxes into a rounder glow. Central black holes, should both galaxies possess them, may take a long time to find each other in the turbulence. They orbit, they shed energy, they close the gap, and at last they join, releasing ripples in space-time too gentle to trouble your window, but strong enough to cross the universe. It's tempting to label all this as chaos. The better word is choreography. Gravity sets the tempo. Dark matter sketches the stage. Stars and gas take their cues. Over and over, the same steps produce new shapes. What looks like devastation, a pair of spirals torn and tangled, often becomes creation, because the squeeze of gas during an encounter lights the nurseries. In time, the fireworks fade, the turbulence smooths, and a fresh galaxy glows with the combined mass of its parents, calmer than the spectacle that birthed it. Understanding leans on a few numbers, but they don't have to shout. A typical bright spiral such as the Milky Way holds on the order of 2 to 400 billion stars. The disk stretches roughly 100,000 light-years across. The unseen share of mass, dark matter, outweighs the visible by a wide margin, about 5 to 1, on average enough to keep everything bound. The count of galaxies in the observable universe reaches into the trillions. These are guideposts, not walls. They remind us that scale is the main character and that patience is the measure of every change. The story of why galaxies look the way they do begins in the same place as the story of how anything exists at all. Without gravity, matter would have drifted thin as fog forever. Without dark matter, the fog that did gather into disks would have spun itself apart. Because both are present, stars formed, planets collected, chemistry began to write its many languages, and living beings eventually looked up and wondered why the sky has a texture. Every breath leans quietly on these forces doing their work in the background. Even the familiar constellations remind us of motion. To your eyes, the patterns hardly budge over a lifetime. To a longer gaze, they shift, slow as continents. The Milky Way's arch looks steady, but deep within it, tens of thousands of stars, complete orbits no human will witness to the end. The calm you feel looking up is real. but it sits on a moving floor. That is not a contradiction, it is a kindness. The universe shows its speed as serenity. The first hints of the unseen came from how stars move around galactic centers. The outer stars were circling faster than the visible mass could explain. The conclusion was not a wish, but a measurement. Either gravity behaves differently than expected on those scales, or there is more mass than meets the eye. Decades of observation across many galaxies found the same pattern. The simplest answer is the dim one. Dark matter forms extended halos that cradle the luminous disks. Telescopes now use colliding clusters and distorted starlight to map that halo's hand, tracing its presence as surely as a river marks a valley. All of this shapes how galaxies meet. Because halos are broad and gently overlapping, they start mingling long before the bright parts feel pressed. That early, invisible conversation guides the outcome. Some mergers leave behind plump, smooth ellipticals. Others, especially when gas is rich and orbits align, keep a memory of spin and grow a new disk. Either way, the emergent galaxy holds the mass together more strongly than either parent alone, an inheritance sealed by time. Imagine standing far outside our system, beyond the faintest outpost of our sun's influence. The darkness would feel full rather than empty, speckled by enormous, soft-edged cities of stars. Each is a living archive. Each page is a star, each paragraph a cluster, each chapter a long arm threaded with dust. The Milky Way is one such book in a library that doesn't end, already annotated by brushes with neighbors, already preparing for a meeting written into its future. None of this requires worry. The timescales are oceans, and we are waves that ride only the topmost inch. The grace of it is easy to miss for the price of a single metaphor. A car crash, a smash, a bang. Those words belong to days and rooms and moments. Out where galaxies gather, there is another vocabulary draw. Lean, braid, soften, settle. The universe does not love violence for its own sake. It loves structure. Where there is disturbance, there is also design. Where there is tearing, there is joining. Where two disks cross paths, tides of light spread out, and in the long quiet afterward, a new outline appears, rounder or broader, or barred in a different way. Think of the Milky Way and Andromeda drawing closer, year after year, with no one on any world feeling the wind of it. Tides will rearrange the outskirts first. Starbirth will ripple through compressed gas. The central regions will dance in tighter loops. At last, the cores will blend, and what remains will be a single, larger galaxy with a calmer heart. The night sky on far future Earth, if Earth still watches, would change slowly across many lifetimes. Constellations pulled in unfamiliar directions, an arc of starlight thickening. For most creatures, the universe would remain the same daily companion it is now, dependable, spacious, and kind. The more you dwell on these meetings, the more gentle they feel. The scale is what does it. Spread a hand on a map, and the miles shrink. Spread a mind across billions of years, and even collisions become invitations. Gravity does not hurry. Dark matter does not boast. Stars follow their curves, and from a vantage just outside our briefness, the whole thing looks like a slow embroidery. Thread by thread, crossing and recrossing, a pattern appears that wasn't obvious at the start, but feels inevitable once you see it. So, what happens when galaxies collide? Stars mostly pass by stars, because the space between them is vast. Gas meets gas and lights new suns. Shapes stretch and relax. Central black holes take their time and then unite. dark halos merge like overlapping breath. The result is not wreckage, but redesign. The universe, faithful to its habits, turns disturbance into form, and under all the motion runs the same soft current that keeps a galaxy whole. Gravity's tug, steady as a heartbeat, and the wide, invisible kindness of dark matter, holding the lantern upright while it spins. To see why the dance unfolds this way, tilt the view backward in time. Not long after the universe first brightened, about 13.8 billion years ago, the great expanse was mostly hydrogen and helium, spread so evenly it looked like calm water at dusk. Hidden in that calm were tiny ripples, barely there thickenings, little swells in the sea of matter. Gravity has a fondness for imperfections. It leaned into those slight advantages, gathering more material where the density was just a whisper higher. What began as a soft imbalance became, over vast spans, the first clumps of stars and the earliest scrappy galaxies, small, irregular, luminous, with youth. From those tender beginnings came the filaments and halos that now guide every quiet merger, the ancient scaffolding beneath today's gentle collisions. Those first galaxies didn't yet know symmetry. They were wild seedlings pushing through new soil, rich with gas and ablaze with newborn blue stars. Time fed them. Inside each one, stars lit, lived, and fell quiet, returning enriched material carbon, oxygen, iron to the gas around them. With every generation, the mix deepened, the palette broadened, and the possibility for planets took root. Light shifted slowly from the eye-stinging blue of youth toward a warmer, golden hush as the youngest stars grew rarer. Outside each galaxy, the neighborhood was busy too. Encounters were frequent in that early crowding. Long meetings unfolded over hundreds of millions of years, not in shocks, but in prolonged tides. When one galaxy brushed another, stars mostly sailed past on their private paths. Yet the shared gravity pulled shapes thin and long, and gas compressed into fresh nurseries. Destruction was the wrong lens, growth fit better. Without these tangles, today's giants would be smaller and duller, missing the history that swells their light. Across billions of years, the record of mergers thickened. The great ellipticals that now sit in cluster centers likely carry the layered memory of many unions. They glow like old cities where avenues have been paved over by time, their stars older, their gas quieter. Even our spiral home is in spotless history. The Milky Way bears told on itself marks faint rivers of stars that once belonged to smaller companions, now braided into our halo. And somewhere ahead, a rendezvous waits with Andromeda, written into the drift long before anyone named the constellations. A galaxy's life moves from restless to reflective. Spirals, so bright with blue knots and threaded dust, can spend their gas and slow their star birth, the color turning redder, the pace hushed. Many gentle mergers later, the arms blur, the disk rounds, a smoother shape takes over. By then, most stars are elder lamps, burning steadily as their fuel thins. The galaxy doesn't go dark. It settles, like a bustling town at twilight when shops have closed but windows still glow. The calendar that holds all this is almost unreachable by human hands. To say a single approach, brush, and coalescence lasts hundreds of millions of years doesn't land easily in the mind. Agriculture, writing, cities, our shared experiments span only thousands of years. Dinosaurs rose and bowed out in a few hundred million, one thin chapter in a single galaxy's book. So the galaxies go on, unhurried. They keep their own hours, and entire species flower and fade, while the grand wheel barely shifts a notch. There's comfort in that patience. The cosmos leaves room for cycles to complete. Collisions, mergings, the rise of new stars. These aren't interruptions. They are the rhythm itself. Galaxies are not delicate the way a single world can be. They are communities, held by many hands. Encounters that would shatter a smaller thing merely reroute a galaxy's traffic, peel out a few streams, kindle new neighborhoods, and widen the city limits. The Milky Way's sky offers evidence in the quietest graffiti. Astronomers track long, gauzy arcs, remnants of dwarfs folded in. Each faint ribbon is a page from our past, proof that we have never lived alone. Some galaxies drift where the crowd thins and decades pass like empty streets. Others sit in clusters where meetings are guaranteed and evolution runs brisk. The same music played faster. That variety spirals with sweeping arms, rounded ellipticals. Unruly irregulars is not a catalogue so much as a snapshot mid-journey. A spiral's grace can soften into an ellipse. An irregular's tangle can be combed by time and tides. Gravity sculpts with a steady palm. Chance provides the chisel marks that make each piece singular. Thinking at this scale reshapes what urgency means. Our clocks tap out seconds. Galaxies lean into centuries of millions. The contrast doesn't make a human hour smaller, it makes the room bigger. There's space enough for every story. The breath of a moth, the patience of a mountain, the long glide of a galaxy. When you imagine a galaxy, you're looking at time made visible. The light that reaches your eyes has traveled for millions of years, carrying the look of a past moment. The galaxy itself continues on, changing in ways we can only catch at the edges of our watching. These aren't mere piles of stars. They are living records of duration, written in orbits and starlight. Words like collision tempt the mind toward noise and flame. But the stage here is too wide for that. Stars are huge to us, yes, but the distances between them are larger still. Picture 2 grains of sand set miles apart. Now let 2 such beaches slide through one another. That's closer to the spacing inside a galactic disk. Even when 2 galaxies interpenetrate, head-on, star-to-star impacts are vanishingly rare. The drama happens in the fields, between the gravity that tugs outskirts into banners and bridges, the gas clouds that actually meet. Those clouds are large enough to collide. Shockwaves ripple, heat builds, the gas loses energy and slumps toward new centers, and suddenly the quiet dark blooms with clusters of hot, short-lived stars. Fireworks, but with the volume turned low, they blaze briefly and end in supernovae that salt their neighborhoods with heavier elements: carbon, oxygen, iron, the alphabet of bodies, and breath spread outward. In this way, a galactic meeting doesn't simply rearrange matter, it accelerates chemistry, laying down the ingredients for future worlds. The orbits of older stars shift too, not through impact, but through the resculpting of the gravitational field. Some are tossed into long, gentle loops far from the new center. Others sink inward, captured by the deepening well. Imagine a planet watching from its stable lane. The constellations would redraw themselves over ages, familiar shapes unbraiding, new patterns slowly threading in. For any creature living a handful of decades, the sky would seem unchanged. The change is there nonetheless, so slow it's a kind of mercy. When partners match in size, the union often erases the clean swirl of arms. The newborn galaxy relaxes into a rounder profile. The chaos of the encounter smooths with age, and stars circle in a quieter, more randomized ballet. Look at a calm elliptical and you're seeing the healed scar of ancient unions, not a wreck, but a new face that remembers the old. Many meetings are unequal. A large galaxy absorbs a smaller companion over long arcs, tidal forces teasing it apart. Astronomers call the process cannibalism with a wink. There is nothing gruesome in it, only patience. The small galaxy's stars and gas are delivered in streams, the way a river brings silt to a delta. Faint tidal ribbons around many galaxies tell this story long after the meal is finished. The Milky Way is mid-supper, pulling in several small neighbors. Their remnants hang like ghostly trails around our home. Gas is the material that most obviously changes the plot. Unlike stars, gas clouds feel direct friction and shock when they meet. The collisions set off waves that help the gas shed energy and slide inward. There, near the center, the flow can awaken the black hole waiting like a pilot light. Feeding resumes, the core brightens, and an active galactic nucleus ignites a beacon powered by matter spiraling close to the event horizon. Sometimes the flare becomes so strong we call it a quasar, outshining the entire host galaxy for a while. Collisions can turn a quiet heart into a lighthouse, visible across cosmic distances. Pace remains the quiet constant. A first approach stretches over hundreds of millions of years. The pass-by doesn't conclude the affair. Partners pull apart and circle back, like tides returning, each loop pulling more structure loose. Only after perhaps 1 billion years does the merged system settle into something that will be itself for a very long time. In that span, on a world like ours, life can climb from simple cells to bodies with hands capable of writing about distant galaxies, then fall silent again without ever witnessing the whole arc of a single union. The sky offers examples that serve as memory and forecast. The antennae two spirals mid-embrace throw out slender, shining arms that curl like insect feelers. Those are tidal tails, the outer stars, rethreaded by the encounter into long streams that shine for hundreds of thousands of light years. Elsewhere, the whirlpool shows how a smaller companion can tug at an orderly spiral, pulling one side a bit wider, brightening knots of star formation along the arms. Every such system is a frame in a very slow film. Add them up, and the movie plays in the mind. The patterns are so striking that the language of dance keeps returning. Ribbons of starlight arc outward. Bridges of matter reach between partners like glowing handshakes, and thin streams loop around the new whole, faint and elegant. Some tails fall back over time, folding their stars into the remnant. Others remain as delicate scars that the dark will carry for billions of years. The beauty grows deeper when you look beyond visible light. Ultraviolet maps the bursts of newborn stars sewn into the tails. Infrared warms where dust is heated in nurseries. Radio tracers reveal hydrogen gas stretched faintly across distances the eye can't hold. The fuel highways that make the next generation possible. Layer these views and the scene resolves from chaos into composition. The encounter is not a wreck. It's a careful score played at a tempo the heart can't rush. There's a softer truth beneath all these displays. Galaxies can be busy or quiet, crowded by neighbors or left to drift, but none are statues. They age, they absorb, they change clothes. Underneath the variety runs a plain mechanism, gravity guiding, gas responding, stars bearing witness, and the long patience to let outcomes settle. The fiercest looking moments grow tender when stretched over proper time. Two disks leaning into one another appear to shred. What they're really doing is redistributing inheritance and building a steadier center. Every so often, it helps to return to scale. Picture standing where no sunlight reaches, past the last cold outpost of our system. The dark is full, not empty. Soft-edged cities of stars glow at distances that make minutes meaningless. Some are seedlings, uneven and promising. Some are ancient capitals, smooth-faced and quiet. Between them, threads of earlier meetings still hang, thin as whispers. In our own city, faint rivers of starlight show where strangers became family. Far ahead, another city approaches, slow as a thought that won't be hurried, and the meeting already has a name written in future skies. All the while, the elemental exchange continues. Gas meets gas. Stars are born and spend themselves. Supernovae seed the field. Black holes take a meal and dim. Tails unfurl and are gathered back. A bridge glows, then folds inward. The lights don't go out. They move to different rooms. We keep the word collision because we lack a single phrase for slow redesign that begins far out and ends in a calm new whole. What looks like ruin at first glance is almost always renewal at the galaxy scale. They don't break. They rearrange, guided by a force that never tires and a patience that outlasts our worry. To watch that patience in full, we borrow another kind of scale, time itself, folded small. Telescopes catch these meetings mid-gesture, but the whole dance only appears when we compress the ages. On quiet screens in dim labs, astronomers set up galaxies like constellations of tiny tokens, millions of particles standing in for stars, gas, and dark matter, and let gravity write. Two disks are given a path. The code hums. In seconds, billions of years pour across the display. Spirals lean, bridges rise, filaments sweep outward like silk unrolling in slow air. Cores settle, light redistributes. What appears matches the sky so closely that the math recedes and a feeling takes its place. It doesn't seem like calculation, it feels like memory. The rhythm is the law itself, not shouting, not tearing, simply the patient arithmetic of attraction. Galaxies approach, overlap, drift apart in a soft recoil, then circle back to finish what they began. Tails curl, loops tighten, cores trade momentum like dancers exchanging weight. Where gas meets gas, new light pricks on. Where orbits are stirred, old stars take new paths. In the end, the fuss calms and a single body settles, a new outline smoothed by time. Watching it unfold at speed is like hearing a symphony in a heartbeat and still feeling every note land. The shapes that arise call to familiar arts. Tidal arcs look like thin brushstrokes, a wrist's gentle curve repeating across a black canvas. Great loops of star stream read as calligraphy, elegant and deliberate, as if meaning could be written in light. Bridges hang between partners like ribbons caught in a breeze. None of it is staged, and yet it answers the same part of us that quiet museums reach, the room in the mind where we stand still and let wonder work. What soothes most is the tempo. The word collision suggests alarm. The sky prefers a lullaby. Every step of a meeting stretches over hundreds of millions of years. The dramatic frames we love, two bright cores close enough to share a halo. Two tails sweeping back like comets are serene when seen from far away. The scale itself is the hush. Even turmoil becomes gentle when each moment is as long as all of human history laid end to end. Some systems wear the story openly. The antennae, about 45 million light-years away in Corvus, appear as two spirals sharing one bright breath, their centers glowing, their long tails arcing outward like curved feelers. In those tails, dust and gas have been squeezed just enough to spark clusters of hot newborns. Blue light glitters along the ribbons like dew catching dawn. Everywhere you look, the system is alive. And yet the arrangement keeps its poise. It's not disorder, it's energy finding its path. A more unusual figure turns up where a small galaxy crossed the heart of a larger disk. The cartwheel, roughly 500 million light-years away in sculpture, wears the imprint of that passage as a ring. The intruder's plunge sent ripples through stars and gas the way a stone sets circles moving on a pond. As the wave front traveled, it compressed the medium, igniting starbirth across the expanding edge. Now, a glowing wheel surrounds a quieter hub, with faint spokes tying ring to center. Science names it a ring galaxy and tracks the physics of shock and compression. The eye sees a design too clean to be accident and has to remember that nature is allowed to surprise us with symmetry. What rises with the spectacle is its brevity. Tidal tales fade as stars disperse. Bridges fall back or are digested. Thin streams blur into the halo and become part of the background memory. The poses that catch our breath last only a few 100 million years before they soften. On the scale of a galaxy's life, that's only a pause. The gift is that our chapter happened to open while these pages were visible. To witness them at all is a small mercy offered by time. Simulations teach the same lesson from another angle. Run after run, varied in mass, in angle of approach, in how much gas each partner carries, all yield patterns that repeat with difference familiar arcs, familiar bridges, familiar rings endlessly recombined. Change one ingredient, and the dance takes on a new accent, yet the music is clear. Gravity guides the steps. Dark matter widens the floor. Gas writes crescendos where it is pressed. The rules are simple. The outcomes feel infinite. The whirlpool, Messier 51, lives about 23 million light-years away and faces us full on. So its spiral looks almost too perfect, a textbook of grace. But the elegance has a co-star, a small companion, NGC 5195, tugging visibly at the outer pattern. The arms wind in tighter on one side, flare open on the other. Dust lanes etched like pencil shading, pink knots glowing where massive stars are being born. The lesser light, despite its size, pulls with real authority, tightening and teasing, reshaping appearance without undoing beauty. It's proof that not every encounter is a smash. Many are simply edits, gentle, persuasive, and showy in the nicest way. Across these examples, the same dual truth appears. Up close, there are shocks in gas, bursts of star formation, turbulence in orbits. From far away, the curves read as order. Both views are honest. Both belong. The difference is scale, and scale is everything in a universe that is never in a hurry. When you glide your attention outward, the chaos resolves into design. When you lean in, you hear the workshop sounds of creation. Fame follows the systems that wear their drama on the outside. The antennae, with their long tails bright enough to trace by eye in deep exposures, are a tidy laboratory. Visible light shows blue clusters along the arcs. Infrared catches the warmth of dust in nurseries. Ultraviolet maps the hottest, youngest stars. Radio reveals hydrogen dragged out into the countryside, the raw fuel for whatever comes next. Layered together, the portrait stops looking like violence and starts sounding like composition. You can point to where the gas lost energy and sank inward, where clusters bloomed like wildflowers after rain, where older stars were flung to new, slow orbits that will one day settle into a calmer whole. Given a few billion years, The overlapping cores will grow into one center. The tails will fade, and what remains will likely resemble a broad elliptical quiet on the surface, with history woven through every orbit. The cartwheel offers different lessons. Its ring marks the leading edge of a wave that keeps moving outward, the way a ripple spends itself. Behind the ring, stars age out of their blue blaze into warmer tones. Ahead of it, gas waits for the pressure to arrive. The spokes hint at paths where material fell back toward the core, along lanes cut through the disk. Nothing about it feels rushed. Even the oddness is patient. The whirlpool's beauty rests partly in timing. We're seeing it while the companion still orbits just right to tug the arms and light them up with birth. The drama will settle. The small partner will be absorbed. The textbook spiral may soften into a different face. For now, the snapshot holds. The arms look like the careful gesture of a painter circling a canvas, and we get to keep the picture as long as that stage lasts. From a distance, all of this quiets the mind. Picture a wide floor of dark where galaxies move like couples at a slow waltz. No sudden steps, no sharp turns. Only the steady persuasion of gravity, a hand at the back, a gentle lead. Each dancer trails ribbons of starlight that sweep as they pivot. Seen that way, the show is not only grand, it is restful. The universe is not trying to startle you. It is demonstrating how structure can emerge from patience. None of these shapes were made with an audience in mind, and yet they work on us like music. They remind us that physics, which can sound cold when written in symbols, is also a language for beauty. Tidal arcs, bridges, rings, these are equations translated into light. A law as simple as masses attract becomes architecture, pattern, and grace, once granted time and space enough to play. The celebrity of certain galaxies says more about us than about them, but it helps focus attention. The antennae are the headline act, all flourish and long lines. The whirlpool is the glamorous portrait, classic features made more striking by a companion's mischievous pull. The cartwheel is the avant-garde piece that didn't fit any category, then made a new one. Together they form a small gallery of outcomes, mid-merger theatrics, gentle tidal editing, and the rare ring drawn by a direct plunge. Everywhere else, quieter examples gather without fanfare. Some are faint pairs in small groups. Some are distant smudges where only the radio map tells you a bridge exists. The universe is generous with variety. What ties the gallery together is impermanence. The tails will thin, the bridges will drop, the ring will fade as the wavefront slows and the stars it made grow old. The snapshots we love are fleeting chapters, a few 100 million years long. That is short enough to feel tender about, long enough to be sure the universe doesn't mind giving us time to notice. Behind the scenes, simulations keep testing and refining the story. Adjust the angle of approach, and a tail shifts its curl. Increase the gas fraction, and the starburst swells. Change the masses, and the final shape rolls from a puffed oval back toward a disk. Put the pair inside a larger group where other halos tug at the edges, and the outcome tilts again. Each run is a thought experiment with gravity and time. Each confirms that the arc from disorder to coherence is no accident. Complexity blooms from simple rules if you let them work. The lesson returns to scale and patience. Up close, a colliding pair is busy shocks, winds, glowing knots that flare and dim. Step back, and you see braided light tracing orbits like rings in a tree. Step back farther, and the pair becomes one more motif in a cluster's tapestry. Keep stepping, and clusters link into filaments, and filaments outline a web so large It feels like a lullaby hummed by space itself. The same dance at different tempos, the same law drawing different figures. Look long enough, and you begin to accept the kindness hidden in the word collision. Among stars, the odds of a direct hit are slim. Among clouds, a meeting makes new suns. Among orbits, a little chaos yields a calmer center. What changes is not the will of the universe, but the arrangement of its light. The antennae will relax into a single glow. The whirlpool will fold its companion into a new face. The cartwheel's ring will pass, leaving a memory written in the ages of its stars. We, here for a moment, get to watch and feel the quiet of it settle around our own breathing. If there is a single thread to pull from all these scenes, it is that gravity writes poetry when given time. A law becomes a line, a sum becomes a sweep, and what we expect to be loud arrives as calm. The screen in the dark lab plays the film again. Approach, overlap, tail, bridge, starbirth, return, union, rest. The sky holds the same frames at full size. Between them, understanding grows without breaking the spell. You can know why the arcs curve exactly so, and still feel them as ribbons. You can measure how fast a ring travels and still lose yourself in its perfection. The universe does not mind being both lesson and lullaby. And in that lullaby, the softest note is also the deepest. Deep in the centers of great star cities, there is a weight so concentrated, it turns silence into presence. Nearly every large galaxy keeps such an anchor, a supermassive black hole packing millions, sometimes billions, of suns into a region smaller than our solar system. You cannot see the black hole itself, but you can read its handwriting. Stars near the core race as if late for an appointment. Gas drifts inward and heats until it glows. Sometimes an entire galaxy brightens, not because the black hole shines, but because the matter falling toward it does radiating fiercely as it spirals down. In the gentle redesigns of colliding galaxies, these anchors wake and dine, and the poem that gravity writes gains a darker, brighter rhyme at the heart. This compact heart and the surrounding galaxy keep score together. The mass of the black hole links, quietly and reliably, to the heft of the galaxy's central bulge. Bigger bulge, bigger black hole, a partnership written into the architecture. They appear to grow side by side across billions of years. Stars are born, die, and enrich the gas. Gas feeds the black hole. Winds and jets from that feeding can heat or sweep the remaining gas, slowing or sparking future starbirth. Each nurtures and restrains the other, a feedback that keeps the city from burning too fast or dozing too long. When galaxies meet, that partnership enters a new chapter. Picture two spirals on a slow approach, each with its own dark heart. Tides stretch their disks, arms unfurl. Gas is funneled inward. Over millions of years, the centers drift closer until both black holes share the same neighborhood. At first, they circle distantly inside the merged remnant, two heavy lanterns tracing wide loops. Friction with surrounding stars and gas saps their energy. Their orbits shrink. The pair becomes a binary, the most intimate of gravitational bonds, and the dance tightens. As they whirl, their motion shakes space-time itself. Ripples roll outward gravitational waves like the soft rings on a pond after a stone is tossed. Except the pond is the fabric of reality. Each orbit carries energy away on those waves, and the two sink closer still. In the last moments, they spin almost at the speed of light, space rhythmically stretching and squeezing as the waves crest. And then the horizons touch. A single, larger black hole takes the stage. For an instant, The energy released in that merger surpasses all the starlight in the visible universe, not as a flash of photons, but as the pure hush of space-time ringing. Those ripples are not fantasy. Sensitive instruments have felt them. In 2015, a pair of laser interferometers LIGO caught a brief, rising chirp from two stellar mass black holes colliding more than 1 billion light-years away. The signal lasted a heartbeat's fraction, yet it confirmed the waves Einstein's equations predicted and proved that black holes are more than elegant math. They are actors in the world. Since then, dozens of similar whispers have arrived from the deep, each a postcard from a distant union. Larger, slower duets, the kind supermassive black holes perform after galaxies merge, sing in deeper tones than ground-based detectors can hear. To catch those notes, a space-borne observatory is being prepared. LISA, a triangle of spacecraft separated by millions of miles, listening for rumbles that unfold over months and years. When that ear opens, it will trace the courtship of giants, telling us how galaxies grow, how black holes feed, and how gravity behaves where it is both gentle and absolute. Black holes can sound like pure appetite, but their role is double-sided. Close up, they devour anything careless enough to wander within reach. At greater distances, they sculpt. Outflows and radiation from an active center can shut down reckless star formation or, under the right conditions, compress gas and help it ignite. After a merger, the new central mass steadies the remnant's heart, a deeper anchor for the combined light. Even the waves they send across the cosmos become part of the universe's memory, a record that outlives any star. If all of this stirs unease, scale offers comfort. When the Milky Way and Andromeda finally fold into one another, their central black holes will, in time, meet and merge. Earth sits far from either core. The sun's pull on its planets is so strong at our distance that the distant slow tides of a galaxy-wide reshuffle can't pry the system apart. And long before the two central black holes finish their spiral, the sun itself will be nearing the end of its steady life. The spectacle belongs to the grand stage, not to the daily concerns of a small world. Shift the gaze from the center to a single star, and the mood settles further. Galaxies look dense in photographs, but they are mostly space. If the sun were a marble, the nearest star would be another marble hundreds of kilometers away. Two galaxies can pass through one another, and almost all their stars slip by without touching. For a typical star, a galactic merger is not an impact. It is a change in map. The gravitational field of the whole reshapes, and the star's path is slowly rewritten. Perhaps a circle becomes a gentle ellipse. Perhaps the orbit tilts. Perhaps it joins a long tidal stream. The adjustment takes millions of years, too slow to register in any single lifetime. The star keeps burning as it always has, fusion steady in its core. Seasons on any attending worlds continuing their quiet work. Solar systems endure for the same reason. A parent star's grip on its planets dwarfs the tug of distant strangers. Rarely, two stars may pass near enough to jostle each other's retinues. A planet might be nudged into a new path, or exiled into the dark as a rogue. Such stories are uncommon. Most of the time, even amid the grandest restructuring, the little clockwork of planets continues, indifferent to the rumble of far-off giants. Some stars do travel farther. A subset are lifted into tidal tails, long, faint rivers, wrapping the remnant, or flung to the halo, where they spend billions of years under wide skies. They do not break. Their hearts go on fusing hydrogen to helium, then heavier elements as age insists. From their perspective, The galaxy is scenery that shifts slowly, not a home that collapses. The quiet is not universal. Where gas meets gas, the pace quickens. Colliding clouds shock, cool, and compress. Starbirth surges in bright knots that shine blue and fierce, living fast and dying young. Supernovae follow, returning carbon, oxygen, iron materials for rock and air and blood to the medium. A merger is, for these stars, a cradle. They exist because two galaxies brushed. Their light is the audible part of the hidden duet. Even the union of central black holes rarely troubles the outskirts. The waves that ring the cosmos pass through those distant neighborhoods like a low note you can feel more than hear, too faint to rattle anything small. Most of the stars keep their habits. The paradox remains. The most striking vistas in astronomy, the elongated tails, the distorted arms, the glowing bridges, belong to events that, for most participants, amount to a subtle change in address. There is a patience running through it all. Stars count their years in eons. A sun-like star burns for about 10 billion years, and it will likely watch its galaxy change clothes more than once. The star's endurance is a kind of promise. While forms rearrange, the lights themselves stay lit. It is consoling to picture our sun drifting on a new, merged orbit in a future sky, still shining, whether or not Earth remains in its care, while the big story plays out around it at a pace that ignores hurry. Return, then, to the centers and the unseen music, two black holes circling, closer each year, space-time humming softly with the energy they shed. A final, graceful meeting. A deeper silence afterward. No audience required, yet we have become listeners. Instruments measure tiny changes in distance, smaller than the width of a proton caused by waves from far-off mergers. That sensitivity turns the universe into an audible place, where gravity itself can be heard doing its delicate work. The photographs of colliding galaxies tempt the eye with altered silhouettes, spirals pulled into ribbons, bridges arched from one core to another. But the truest changes begin where nothing sparkles yet. In the dim scaffolding of disks and halos lie reservoirs of gas and dust, invisible to ordinary sight and vivid in radio and infrared. When tides guide that material inward, or gather it into compressing lanes along the arms, star formation wakes like rain, returning to a dry field. A galaxy's outline shifts, yes, and more quietly, its future is rewritten as thousands of small lights take their places. This is how a meeting of giants becomes creation. How tonight's disturbance seeds a sky for worlds that do not yet exist. Lean closer, and the quiet material between the stars stops being ordinary. A galaxy is veiled in a thin mist of hydrogen, laced with tiny grains, carbon, silicon, and heavier notes from older lives. Those specks scatter starlight, softening what we see. The gas carries the chill and promise of space. Together they are fertile soil. Without them, a galaxy is a lantern running out of oil, a place of elders with no children. With them, it is a nursery, waiting for a gentle shake, and a collision is exactly that. A slow, patient stirring that turns darkness into rooms with lights on. A meeting provides that shake. Tides tug at drifting clouds, squeezing them. Sometimes clouds strike each other directly, their shock fronts piling up like slow waves. Pressure rises, temperatures change. Gravity finds a better grip. Knots form inside the knots, and those densest pockets collapse into protostars. Heat builds at their hearts until fusion lights hydrogen, touching hydrogen to become helium, and a new point of light joins the city. From the outside, a disruption seemed to pass. From the inside, 1,000 small dawns began. Astronomers call these fevered intervals starbursts. For a while, a galaxy can kindle new suns tens or even hundreds of times faster than it does in its quieter years. Long still regions flush with pinks and reds as ultraviolet light from newborn stars ionizes hydrogen around them. In images of a system like the antennae, clusters of fresh blue stars bead the torn arms like dew. Each glow marks a nursery, where gravity and shock have finished their long negotiation. Life cycles accelerate. The most massive stars blaze briefly millions of years, not billions, then shrug themselves apart as supernovae, scattering carbon for breath, oxygen for oceans, iron for blood. The fireworks feel brief to a galaxy, but they re-season the entire kitchen. Nebulae carry the music of this change in color. Filaments glow where shock waves pass. Knots deepen where tides compress. Through a telescope, the palette tells the tale. Ruby swaths of hydrogen, minty veils of oxygen, hints of helium blue, dust lanes like soft charcoal strokes. These are gardens in bloom. Gravity did not come to ruin them. It came to prune and plant with a wide, patient hand. The gardener's work runs large. A single bright complex can hold thousands of suns in the making. Some will be steady and long-lived. Some will live fast and end as neutron stars or black holes. Some will cradle planets where chemistry has time to experiment. That a meeting spanning hundreds of millions of years can set the table for future worlds lends the spectacle its gentlest meaning. Encounters do not merely rearrange, they beget. Beneath the beauty is simple, elegant physics. Tides draw gas inward along lanes and bars, thickening the central regions. Feeding can wake the core black hole, turning a quiet heart into an active nucleus, even a quasar. Yet the same inflow and the same compressions ignite star formation from center to outskirts. Patches of brilliance appear across the disk, a quilt of glowing knots stitched by gravity's steady hand. Bursts by nature end. Fuel runs low. Winds from hot stars and shocks from supernovae stir and heat the gas, pushing some of it out, stretching some thin. A few 100 million years is enough to shift a galaxy from exuberant to reserved. What remains is redder, calmer, older in its light. Collisions not only plant, they also harvest. They speed evolution along, pressing a system from lively youth toward a measured middle age. Soil, turned intensely, must rest. Catching a starburst is like opening a book and finding a paragraph highlighted by the author. Most galaxies spend longer intervals in quiet growth. To see one alight with newborn clusters is to witness a rare mood, a second wind arriving on schedule only the cosmos keeps. Renewal flares where chance, proximity, and the deep pull of matter cooperate. There is balance woven through the cycle. Gas that might have wandered for ages is invited into stars. Those stars cook heavier elements and return them to the medium. Collisions stir that enriched mix and seed the next generation. Nothing is wasted, even the drama. The universe composts its light. From our far vantage, eyes and cameras catch the colors with surprising tenderness. Arcs of emission line the torn structures. Faint bridges connect cores like handshakes made of fireflies. Each image is a chart and a painting at once, both record and reassurance that creation thrives even in the midst of change. After the blaze, a long exhale. Tidal tails lengthen and thin. Some stars fall back, others settle into the halo. bridges collapse into the growing center. The two original identities soften into one. Gravity keeps tidying. Thin rotating disks that once supported clear spiral arms are jostled beyond repair. What takes their place is usually rounder, a broad, smooth glow we call an elliptical. The shape says as much about motion as about form. Orbits that were once aligned in a thin plane have been scrambled into every direction, filling volume instead of tracing a sheet. The light from these new shapes is warmer. Without ample gas, few blue beacons persist. The galaxy is lit by older, cooler populations that favor gold. No long filigree of arms, no restless dust lanes, just a steady, even radiance. The look is not austere, it is composed. In crowded clusters, this maturity is common. Near their centers, ellipticals swell into giants, their bodies built from many unions, their halos laced with the soft, ghostly streams of former satellites. Some hold trillions of stars, their sheer mass turning them into anchors for their neighborhoods. They are mosaics of histories, their calm a sum over countless past excitements. Quiet does not mean empty. Stars still orbit, each finding its own loop through the common field. A central black hole waits and sometimes feeds if a stray bit of gas drifts too close. Globular clusters dense, ancient bowls of stars continue their slow patrols, but the pace is different. The background hum lower. The great commitments of structure have been made. The system's long work now is to endure. For a long looker, there is comfort here. Turbulence has a way of convincing us it lasts forever. Physics, given time, shows how often it doesn't. After the brightest surge, a system learns to hold itself with less effort. The glow that remains is not the absence of drama. It is the sum of it, settled and spread out. The path to this stillness is a story of orbits and fuel. Collisions randomize motion. The tidy rotation that feeds spiral arms gives way to a jumble of directions, so no preferred plane remains to maintain the lacework. At the same time, the gas that once fed nurseries is spent or heated and expelled by supernova blasts and by winds from active nuclei. With little left to form new stars, the population ages together, gradually dimming, the color leaning deeper into autumn. Some of the most massive ellipticals we see today likely finished their main growing seasons long ago. Their smoothness and their lack of star-forming regions speak of repeated past collisions followed by disciplined calm. To see one is to read the closing chapters of many books bound into a single cover. Each chapter, once wild with conflict and romance, now resolved into quiet strength. The stage is calmer. The actors still do their parts. Red giants swell and shed, white dwarfs cool, neutron stars and black holes pass through their private destinies. Occasional infall from small neighbors throws a pebble into the pond, sending ripples through the halo. The rhythm, however, has lengthened. If a spiral is a dancer caught mid-turn, an elliptical is the pose held afterward, muscles steady, breath even, grace intact. This quiet may last longer than language can name. If the universe keeps expanding and cooling, if gas continues to thin and star formation dwindles, these elders will remain as the last bright witnesses, their light soft but persistent. They are not the ashes after a fire, they are the hearth that continues to glow. Returning to the gardener's metaphor, the seasons show themselves cleanly. A collision turns the soil, seeds rush to sprout, flowers blaze, the harvest comes, fields rest, and the landscape settles into a graceful winter. Nothing wasted, nothing hurried. The beauty of the storm is matched by the beauty of the calm. The galaxies teach it gently. After great change, find your balance. After noise, listen for the steadying hum. The eye is naturally drawn to the dramatic frames, the torn arms and bright knots. The cores aflame with feeding, but the final portrait has its own gravity. A smooth oval, golden against the night, silent from a distance, busy inside. It is the look of endurance. It is a reminder that even the most elaborate transformations arrive at a place where light can simply be light, where a system knows itself again, where the universe, without fanfare, rests. Face the quiet patch in Andromeda's direction, and the night offers a smudge, almost nothing, almost a mistake your eyes could blame on themselves. That blur is a city of stars, the Andromeda Galaxy, kin to our own. A spiral with hundreds of billions of suns and the soft scaffolding of dark matter holding it together. It is not merely passing through the neighborhood, it's coming to the door. The approach is real, but the clock ticks on a scale that turns alarm into lullaby. Roughly 4 billion years before the first true encounter, with the continents on Earth long rearranged, the sun a little hotter and brighter, and whatever calls itself human, living in ways we can't rehearse. The motion has been measured with patient care. Andromeda drifts toward us at about 110 kilometers per second, across more than 2 million light-years. That speed becomes the slowest kind of certainty, like two ocean liners gliding toward a meeting you can predict, but will never rush. The outcome is written, the feeling is calm. As the date approaches, Andromeda will swell in the sky, graduating from faint haze to a luminous disk, and then to a presence so large it remaps the night. The spectacle won't be a crash. Stars will slide past stars because space within galaxies is mostly space. The drama will live in the shapes, the way tides draw out long ribbons, the way bridges of starlight grow, the way gas meets gas and turns dark lanes into nurseries blazing with newborn blue. The first deep pass will fling out great tidal tales, arcs of stars and dust unspooling into the dark. Gravity will gather both galaxies again, and again they'll fall into each other, each loop stirring, each loop reshaping. The courtship lasts billions of years. When the motions finally calm, the merged system will likely wear a rounder face, an elliptical, larger and smoother than either parent. Some give it a shy portmanteau, Milkomeda or Milkdromeda, a playful nod to the two lineages folded into one glow. Somewhere inside that future outline travels our small system. Destruction is unlikely. Displacement is almost certain. The sun and its planets may drift outward to wider orbits, or sink inward to a nearer lane, or sail along a tidal stream as part of a thin, quiet river of stars. The sky, if anyone looks up, will trade its familiar constellations for strange alphabets. Two spirals will once appear overlapped, arms weaving like threads on a black loom. Starburst knots will glitter more brightly than the usual background of galaxies. Yet all of this will change so slowly that no single generation will watch it unfold. They'll inherit a sky slightly edited from their grandparents' version and pass along another slight edit in turn. The meeting reminds us that galaxies are not solitary artists. They live on a web, moving along filaments of dark matter, tugging and being tugged, drifting into gatherings and unions. The catalogue of the heavens is full of aftermath, smooth ellipticals that hold the memory of older structures in the quiet of their orbits. It is humbling to see our Milky Way as a temporary style, a snapshot in a long album, beautiful because it exists, not because it lasts. The same arms that frame our star's neighborhood will someday soften, the same constellations will someday unthread, and the same city of light will find itself rebuilt on new streets. Scale carries its own humor. We fret over schedules, over a weekend plan, over a buffering video, while the universe has penciled in a meeting that will reshuffle hundreds of billions of stars and then generously scheduled it for 4 billion years from now, give or take a few hundred million. That's the gentlest deadline a cosmos can offer. Nothing to cancel, everything to enjoy. The soft smear you see in Andromeda's place has been traveling for more than 2 million years, just to touch your retina. Behind that light is momentum so steady, it will alter the shape of our home galaxy. 2 star cities on converging lanes will fold together, and from their union a new outline will glow in the dark. No trumpets, only the steady voice of gravity doing what it always does. We are not blind about what's coming. Simulations let us preview this future, compressing eons into minutes. Astronomers feed what we've learned about both galaxies, their masses, their shapes, their motion into powerful computers, along with the rules that govern everything from starlight to space-time. Newton's pull and Einstein's curvature guide the dance. What unfolds on the screen is not guesswork, but a time lapse of law. Andromeda doesn't slam and stop. It threads through, recoils, returns. Tidal streams peel away like fabric in a light wind. After several embraces, the 2 cores come to rest inside a single glow. The most startling part of those films is how gentle the fate of stars appears. Space is spacious. Direct star-star collisions are rare. Orbits change, lives do not. A star may be flung outward to a long, slow path in the halo, or drawn inward to a tighter loop, but it remains itself. To a star, a galactic collision is a change of address. For our Sun and Earth, survival is the likely line. The solar family may move to a new neighborhood. It will almost certainly remain a family. Whether Earth is still kind to life is a separate story. Long before the first pass, the sun's growing brightness could reshape our climate and our oceans. Life, if it continues, will have adapted or moved on. The sky, however, during those long nights of merger, will be a masterpiece no earlier epoch has framed. Watch enough of these digital futures, and a pattern repeats with differences. Long arms stretch and fade, bridges glow and collapse. The final structure is usually an elliptical, featureless only at first glance, deeply textured in its orbits. The name Milkdromeda is a small grin in a serious story. The mass will be vast, the light steady, the size wide enough to feel like a horizon made of stars. Invisible partners do much of the work. Dark matter halos those deep, ghostly cocoons of mass surrounding both galaxies overlap first. Their embrace nails the outcome. Without those halos, the galaxies might shear past each other and continue on. With them, invisible gravity lines are thrown like ropes, ensuring the drift ends in union. And this is not a duet for 2 alone. The Magellanic Clouds, the Triangulum Galaxy, and many dwarf companions are threaded into the same web. Some will be absorbed. Some will become those long, faint streams that lace the halo like forgotten footpaths. The final city will be a composite, its lights gathered from many homes. There's a kind sweetness in being able to look forward so far. A handful of equations, a mountain of computation, and the future stands where we can study it. Billions of years unspool in a sequence someone can pause and rewind. A spiral unfurls, a bridge arcs out, a ring of stars circles a quieting core. The story the models tell is clear enough to feel like memory. Approach, tidal pull, recoil, the long return, the settling of orbits, the calm. Inside that calm, daily life, whatever daily will mean then, will continue. Planets will circle their suns. Seasons, if seasons remain, will keep time. Minds, if minds remain, will find new myths to fold around the changing sky. The grand event will not pause the rest of the universe. No applause, no curtain. Just gravity finishing the work it began when tiny ripples in a young cosmos tilted matter into clumps and sent galaxies drifting toward one another along unseen lanes. The Andromeda smear is destiny and progress at once. It shows that change is not an exception but the rule, written into the structure of everything. Our Milky Way's particular grace is temporary, but so is every stage. What follows is not disappearance, it is continuity in a new shape. The stars endure, the city evolves, and the dance goes on, whether we sit beneath it or not. Shift again to the smaller scale, one solar system within the swell of change and steadiness returns. The sun's pull on its planets is fierce, at 93 million miles. Distant tides from a passing galactic core barely register here. Most systems come through intact. Rare close encounters can jostle or even exile a planet into the dark, turning it into a rogue world with no dawn. But such meetings are the exception that proves the spaciousness of space. The usual story is continuity, fusion in the stellar core, energy flowing outward, a lighthouse beam in a weather the star doesn't feel. Out farther, the Magellanic Clouds may thread into the merger, their gas streams feeding new stars along the way, their stellar populations sprinkled like salt into the larger recipe. Triangulum may join, may orbit, may complicate the choreography in ways simulations enjoy exploring. Each possibility is a variant on the same chorus, and all are guided by the invisible mass that outnumbers what shines. There will be humor in the footnotes. Someone will suggest another nickname. Someone will quibble over whether the final shape is truly an elliptical or a disk reborn from leftover gas. Someone will build better simulations with better initial conditions and finer resolution, and watch a dozen fates bloom from the same beginning. Underneath the debate runs the same melody. Gravity has time, and it uses it. If you could stand through those billions of years, if you could keep a single viewpoint and let the sky rotate through its new faces, you'd see Andromeda swell, overlap, drift past, and return. You'd see tails arch like flying pennants. You'd see bright knots flare and fade. You'd watch the arms lose their lace and the center deepen. You'd see the last long loops settle into a smooth glow. You'd end under a different sky that still feels like home, because home would be wherever your star carries you. There is tenderness in imagining it. Not doom, not rescue, just a continuation. Two grand structures are on paths that converge. Their meeting will make a third, larger thing, and that thing will hold its light for a long, long time. The story doesn't hurry. The story doesn't end. The faint smear tonight is an invitation to feel the patience built into the universe, and maybe to borrow a little of it. The errands will get done. The weekend will come and go. Above all that, quiet and certain, two galaxies keep drifting toward a shared future, and the future is beautiful. The screens that play our simulations are small compared to the sky, but they widen something inside us. We learn that the spirals we love are waypoints. We learn that halos meet before disks do. We learn that stars glide through the great reorganization unbroken. We learn that dark matter's invisible mass writes the outline of fate. Above all, we learn to see the present as part of a longer sentence. Our Milky Way is a clause in a story still being written. In a few billion years, a different grammar of light will take over. The page will turn, the paragraph will continue, the meaning will hold. Far across the dark, the dim blur keeps shining. Its light has already crossed ages to arrive. Behind that light is a slow approach and the certainty of a gentle joining. The name will change, the stars will remain, and somewhere inside that future glow, a small sun will still pour out warmth, a steady signal in a universe that likes to move and to make new shapes and to keep the night alive. In the long hush of cosmic time, collisions have been less like rare storms and more like the weather itself. To feel why, let imagination drift backward, not far after the first light, when the universe was smaller, denser, and everything lived closer to everything else. Galaxies then were not grand spirals and polished ellipses. They were clumpy seedlings, rich with cold gas, forming stars as if they could not help themselves. Distances were short, meetings were inevitable, roots tangled with roots, branches brushed branches, little systems bumped and folded into larger ones, a crowded garden, growing by contact. Deep views with patient telescopes catch that youth frozen mid-breath. Faraway galaxies look warped, misshapen, unfinished, not mistakes, but blueprints in use. What seems chaotic is construction. Gravity drawing lines, gas answering the pressure, starlight turning on in fits and waves. Those early collisions were not gentle. Small, gas-heavy galaxies met and immediately lit with starbursts, clouds slamming into clouds, shock fronts running through them, gravity seizing the advantage and collapsing knots into clusters of hot, brief-lived stars. The fireworks were as fierce as they were creative. In the constant cycle of touch and merge, little irregulars gathered into bigger, more coherent bodies. Astronomers give it a practical name assembly, but the feel is simpler. Many small towns becoming a city, not by decree, but by steady joining. Every galaxy now floating in calm is a palimpsest of that past. Peel back the starlight and you find seams. Streams arc through halos, the torn trails of swallowed companions. Chemical fingerprints hide in stars, subtle patterns of carbon, oxygen, iron that betray the nurseries where they were born. Stars from once separate galaxies carry slightly different recipes, and by reading those recipes, researchers have drafted family trees. Our Milky Way, dignified in photographs, is stitched from dozens of smaller siblings. We are, in the nicest sense, a collection of leftovers arranged into grace. Collisions did more than bulk up size. They gave the universe its variety. Spirals likely rose when gas, calmed after encounters, settled into rotating disks, where gentle density waves could trace arms and coax fresh stars into being. Ellipticals often mark the aftermath of harder unions, two spirals meeting with enough force to scramble their orbits, leaving a rounder, smoother distribution of old light. From rough beginnings came a zoo of forms, all born of the same ingredients played at different tempos. The chemistry of life owes much to this bustle. The first stars had little to work with, mostly hydrogen and helium. Heavier elements came later, forged in stellar cores and flung wide by supernova, especially during those collision-triggered starbursts. Carbon for breath, oxygen for oceans, silicon for rock, iron for blood. These are the ash and treasure of earlier stars. Collisions stirred the pot, triggered new waves of birth, spread metals far and wide, and made it more likely that future clouds would cool, collapse, and build planets. Violence, on the large scale, became fertility. Even the dark hearts of galaxies grew by these meetings. Central black holes began as small seeds, perhaps the remnants of huge first-generation stars, or dense, early collapses and fattened when galaxies tangled. Gravitational tides funneled gas inward, feeding the cores until they blazed as active nuclei or quasars. Sometimes a merger carried two central black holes into the same halo. They circled, tightened their bond, and finally coalesced, sending ripples through space-time that instruments, much later, would learn to feel. The universe wrote its history in waves as well as in light. Evidence lies everywhere for those who listen. Deep surveys catch pairs in mid-approach, bridges faint as whispers, tales long as patience. Closer to home, the Milky Way's outskirts wear gauzy streams like scarves, remnants of galaxies already folded in. Andromeda carries loops and shells, ripples from past meetings quietly decorating its halo. These are fossils you can see with careful eyes, a record of a restless youth that chose order without ever losing motion. Time changed the mood. In the beginning, soon meant hundreds of millions of years. The playground was crowded, collisions were routine, expansion stretched the distances, galaxies swelled. Meetings became less frequent, though still sure. The pace slowed, the habit remained. Even now, the universe keeps a hand on the furniture, shifting it, a little at a time. All of that grand architecture sits atop a more intimate story, the steady lives of stars. Collisions set the stage and rearrange the aisles, but each star keeps its own rhythm. A cold cloud collapses, the center heats, fusion lights, a new sun takes its place. For most of its life, a star is a master of balance. Gravity pressing inward, nuclear fire pushing outward, a quiet truce that can last for billions of years. The sun has been in that equilibrium for about 4.5 billion, and will keep it for about as long again. During that long main sequence hush, light is generous, and any worlds nearby count their days by it. Nothing holds forever. When hydrogen thins in the core, the balance tips. In stars like the sun, the center contracts and heats. The outer layers swell and cool into a red giant. A modest star can grow until it threatens its inner planets, glowing with a deep warmth that belies its changing heart. From far away, the star looks like an ember grown huge. Up close, it is shedding, exhaling shells of gas that drift outward like translucent veils. The fading central light illuminates those shells as planetary nebulae, a misnomer from old telescopes that still feels poetic. They hang for tens of thousands of years and then loosen, returning enriched material to the galaxy. At the core remains a white dwarf, a dense, Earth-sized ember that no longer fuses but glows with leftover heat, cooling by tiny degrees across immense time. Heavier stars live faster. With more mass, their cores run hotter, burning fuel with a bright impatience. They swell into red or blue supergiants, and then, when fusion can no longer support the weight, gravity wins in a single, breathtaking move. The core collapses. The outer layers rush inward and rebound. A supernova blossoms with a light that can outshine a galaxy for a brief moment. In that flash, elements made in the star's heart and in the explosion's forge are hurled into space. The garden gets seeds again. What's left at the center depends on the original heft. A neutron star, small and impossibly dense, spinning and sweeping space with tight beams, or, if the mass was larger still, a black hole, where gravity folds every path inward, and light itself becomes a trapped thought. Place these fates back into the larger story, and the harmony sharpens. Collisions stir gas into starbursts. Starbursts make massive stars. Massive stars die energetically, enriching the medium. The enriched medium cools better and collapses more easily. New generations form with higher chances of planets and chemistry. And on, a spiral of creation built from endings. Meanwhile, most existing stars, especially those far from the centers of encounters, pass through mergers like calm travelers on a train, while the landscape outside changes. Their orbits are nudged, their neighborhoods redescribed, but their cores continue, steady and bright. The early universe wrote this rhythm in bold. When galaxies were small and wet with gas, collisions turned the volume up. Star formations surged. Supernovae rattled the medium. Black holes fed greedily and sometimes joined. As systems grew and gas thinned, the crescendo softened. The music didn't stop. The score learned to breathe. Now the same principles apply across a slower timeline. Neighbors still meet. Halos still pull long before starlight touches. The choreography remains patient and precise. To look up now is to see the outcome of that long, rough childhood smoothed into elegance. Spirals carry on with their turquoise nurseries and dark dust lanes. Ellipticals glow like embers, banked carefully for a cold night. Dwarfs dart around like bright birds at the edge of forests. Each carries history in its motion and chemistry. Each adds its own notes to the background hum. If there's kindness hiding in all this, it lives in the scales. Collisions sound fierce. In practice, they're slow. Stars sound fragile. In practice, they're steady. The universe builds by jostling and rests by glowing. Even the most chaotic processes are craftsmen here. Out of tangle comes pattern, out of noise, a line you can trace with a fingertip across the sky. So the story folds back upon itself with a quiet lesson. Collisions are not interruptions, they are engines. They gathered little galaxies into larger ones, distributed the chemistry of life, raised the great anchors at galactic centers, and kept the universe from freezing into sameness. Every breath we take owes something to that roughness. Every planet's rock and water and iron were once part of a star that lived fast and fell apart, likely in a burst, set off by a meeting between larger things. The serene beauty above us is a recent photograph of a world that worked hard to become calm. Meanwhile, far from the drama, each star tends its own fire. Hydrogen slips into helium. Light lifts. Planets turn. A collision can remodel a city of stars, but in the houses, a lamp still burns. From the edge of time's map to right now, the balance holds. Gravity asks for structure. Fusion pays with light. Galaxies carry both requests through their long seasons. And the night made of all their agreements feels wide enough for everything that is still to come. Stars are small beside their galaxies, yet their stories reach far. Even when whole star cities brush and blend, the fates of individual suns remain steady. They are too widely spaced to collide, too faithful to their own physics to be rushed. A merger does not change how a star burns. It changes how many stars are kindled and where. When two galaxies lean into each other, vast reservoirs of gas are compressed, shocked, and guided along new lanes. Nurseries wake. Whole neighborhoods of newborn light appear, each young star inheriting the same long arc as those before it. A quiet rise, a season of steady shine, and a transformation into something smaller, denser, or darker. Over billions of years, this interplay encounter feeding birth, birth seeding death, death enriching new birth, has woven a calm tapestry from turbulent thread. Many of the points that pierce our night were likely born in such stirred-up seasons. Some will end as supernovae, throwing carbon, oxygen, silicon, and iron into the breeze that future clouds will gather. Others will cool into white dwarfs and join the dim, ancient halo that surrounds a galaxy like a memory. It's a reflective thought that stars live shorter lives than galaxies, and yet they write the ingredients list for everything that follows. Their endings are never waste. They are recipes left on the counter for the next cook. A collision, seen this way, is less wreckage than renewal. It shakes the cosmic snow globe, sets flakes of gas and dust moving, and lights matches across a dark field. Inside those lights are quiet dramas, red giants breathing out shells like lantern smoke, white dwarfs fading by degrees, neutron stars spinning like tight, swift lighthouses, black holes eating with such modesty that only the surrounding glow gives them away. The universe recycles with devotion. Nothing vanishes, it changes job. The atoms that make a hand, a leaf, a stone, most were forged in stars that died long ago, perhaps in galaxies that no longer exist as separate things. From that perspective, even the grandest encounters read as continuity. Each star is a thread, keeping its own rhythm. Collisions are looms. They don't cut, they weave. What a human eye would call an ending is the start of a new pattern, somewhere else, on someone else's night. When astronomers first watched these meetings in detail, gravity and gas played the expected leads. Stars slipped by, clouds collided, disks warped, shapes remade themselves. Then careful mass maps revealed an extra hand on the wheel. Something heavy, everywhere, and invisible to light, was steering the outcomes. That quiet influence is dark matter, the hidden framework of the cosmos. Dark matter does not shine, reflect, or dim light. It ignores electromagnetism entirely, speaking only the language of gravity. We notice it by what it holds together and how it bends what passes by. It tugs on stars at the edges of spirals, keeping them circling faster than visible mass would allow. It warps the images of far-off galaxies into arcs and smears a soft lens made of mass alone. In collisions, its role grows unmistakable. Without it, much of what we witness would unspool differently, or not at all. One scene made the point unmistakably. Astronomers call it the bullet cluster, the aftermath of two galaxy clusters that plowed through each other about 3.8 billion light-years away. Clusters are immense hundreds of galaxies adrift in a bath of hot, X-ray bright gas that outweighs all their stars. During the encounter, that gas behaved like gas does. It slammed, heated, and piled up between the parting clusters, a glowing traffic jam. Then telescopes mapped the total mass using gravitational lensing, reading how background galaxies were stretched by the cluster's gravity. The heaviest regions were not in the hot gas. They had sailed through and now sat around the swarms of galaxies on either side, as if most of the matter felt no drag at all. Visible matter lagged. Most of the mass did not. The separation was the signature. Something unseen, far more massive than the stars and gas, had glided straight through. For many, this was the smoking gun. That same behavior shows up elsewhere. In systems nicknamed with equal drama like the train wreck cluster, Abel 520. The mass sometimes arranges itself in puzzling ways, hinting there may be more to learn about how the dark component behaves. The broad truth holds: whatever dark matter is, it hardly interacts with itself. Halos overlap like ghosts, passing through with little friction, while ordinary gas shocks and slows. That's why galaxies can thread one another and remain bound. Each rides inside a wide, invisible cocoon, and those cocoons pass cleanly before gravity pulls the pair back together. Dark matter is not a backdrop. It is the stage. Spirals spin too quickly to hold their stars without an extra hand. Halos provide that grip. During mergers, halos decide who returns, who escapes, and what the final outline becomes. The newborn elliptical that glows after a long union is sculpted inside its halo's bowl. The bowl's depth and shape guide the settling light. What dark matter is, precisely, stays open. Leading ideas point to exotic particles that rarely touch ordinary matter. WIMPs, short for weakly interacting massive particles. Others imagine much lighter candidates, like axions, humming softly through space. Each collision we map, each lens we read, narrows the options. Across the board, one number keeps appearing. Roughly 85% of the matter is dark. The rest, stars, planets, gas, dust, is the foam on the wave. The swell underneath is what sets the ocean's shape. While that quiet mass holds everything in place, another story unfolds at the centers. Most large galaxies keep a giant at heart, a supermassive black hole, its mass measured in millions to billions of suns. In peaceful times, many of these eat modestly. The Milky Way's own, Sagittarius A*, is a restrained diner, nibbling from thin air. A merger changes the menu. Tides drive gas inward along bars and lanes. Random motions replace ordered orbits. Reservoirs, once circling politely, are herded toward the core. Black holes rarely swallow stars whole. The distances are too broad. What they feast on is gas, and a collision turns on every faucet. As the inflow gathers speed, it forms a bright, hot disk around the hole. Friction there heats the material to astonishing temperatures. Before the gas crosses the event horizon, it radiates across the spectrum radio. Hum, optical shine, X-ray blaze. A once quiet center becomes an active galactic nucleus. A lighthouse so brilliant it can outshine all its host stars combined. Some of these engines twist magnetic fields into tight ropes and launch jets that spear thousands of light years into intergalactic dark, carving lobes that glow long after the feast subsides. Push the feeding hard enough, and the beacon earns an old name with a new meaning: quasar. First mistaken for odd stars, quasars prove to be the blazing hearts of galaxies, whose central black holes are eating at a furious pace. They are so bright we can see them from across much of the observable universe, cosmic lighthouses from an earlier age when mergers were frequent and gas was plentiful. Their light arrives as history made visible, a record of times when galaxies were noisy on purpose so that the future could be interesting. The influence cuts two ways. The same outflows and radiation that announce a feeding black hole can heat and sweep nearby gas, slowing future star formation in the core, or, under the right conditions, compressing pockets that spark it. The black hole and its galaxy keep each other's appetite in check, a feedback that may explain why bigger bulges tend to host bigger black holes, and why neither often grows without the other's consent. All of this, the weaving of stellar lives into new generations. The stage built of invisible mass, the sudden brightness of fed black holes runs inside the same patient tempo. Stars keep their promises. Collisions write new schedules for where promises begin. Dark matter holds the calendar steady. The result is a universe that looks serene at a glance and tells, upon longer listening, the longest story about change. It helps to return to the small. In a typical merger, most stars are untouched by direct harm. Their paths are nudged, their neighborhoods are renamed, their cores never notice. A few end as the brilliant punctuation marks we call supernovae, enriching the air with metals for future rocks and breaths. Many slip into elderhood quietly, embers cooling over spans that dwarf the rise and fall of species. Meanwhile, far away from any core, halos slide through halos, dragging their luminous cargo toward an outcome that feels inevitable and calm. Even the parts we cannot see leave marks we can read. A lensing map acts like a fingerprint. A cluster collision becomes a page in a textbook written in arcs and distortions. Each odd distribution, each case that doesn't line up cleanly, nudges theory forward, reminding us that humility is a tool, not a mood. The sky is generous with hints. We are learning to take them. Somewhere, near the end of a long merger, the black holes at two centers find each other. They circle for a very long while, then closer still, shedding energy as gravitational waves that make space-time ring. The final whirl is fast and bright in a way only gravity can be bright. When the horizons touch, a bigger black hole takes the role of anchor. The light around it will fade, the galaxy will relax, the memory will remain in the orbits, in the star's chemistry, in the halo's shape, and, much later, in faint ripples that careful instruments might catch as they pass. The vision that remains is simple and kind. Galaxies collide, stars mostly carry on, gas becomes stars, stars become the ingredients for new stars. Dark matter, unseen, sets the boundaries. Black holes, usually quiet, sometimes sing. The night we love is made from all of it, from threads that never break, only tie into larger patterns, and from a universe that prefers renewal to ruin. Galactic collisions are uncanny caterers. Left alone, a spiral keeps its house in order, gas in tidy lanes, stars in obedient orbits, the pantry spread evenly across the disk. Tip the house with a merger, and the cupboards fling open. Shocks pucker the gas. Tides twist its paths. What was once distributed is shepherded inward. Central black holes, usually polite eaters, find the tables suddenly crowded with courses, and the quiet core turns luminous. A once ordinary nucleus blooms into an AGN. Push the feeding harder, and it becomes a quasar, bright enough to be seen across a good fraction of the observable universe. A lighthouse made from falling matter and patience. Sometimes the feast is a duet. Two galaxies, two central giants, both supplied by inflowing gas, both lighting up at once. Dual AGN, separated by only a few thousand light-years, their disks humming, their X-rays crackling, their jets sketching lines through the dark. The partnership doesn't last at that distance. Dynamical friction, subtle handshakes with stars and gas robs the black holes of orbital energy. Their orbits shrink. The pair tightens to a bound dance so close that only the gravity between them can keep the steps straight. Long after the fireworks above have softened, the last orbits quicken. Space-time itself rings. The horizons meet. A single, heavier anchor remains. Before that quiet, the energy they pour back into their surroundings changes the whole city. Accretion doesn't only make light, it drives winds. Radiation pushes on dust, jets plow tunnels. Shock fronts write boundaries through gas that once drifted freely. Feedback, in its many guises, can quench exuberance, sweeping fuel out of the central neighborhoods, dimming future starbirth, nudging a galaxy toward the calm hues of an elliptical. Under other conditions, the same outflows compress clouds on the periphery, tipping them into collapse and planting new clusters like wildflowers along a fence. The black hole is not passenger but co-author. Its appetite, woken by the merger, becomes a throttle for how the galaxy lives afterward. This link grows stronger with size. Big bulges tend to host big black holes. Plentiful gas and vigorous merging in the young universe let seeds fatten quickly. Bright quasars glow mostly in the deep past, where their light left when galaxies were clumpy, wet with fuel, and meetings were common. Today, the pantry is leaner. Spirals are larger, more settled. Collisions still happen, but the meals are often smaller, the feasts rarer. Even so, nearby unions can stage dazzling shows. The antennae's torn arms sparkle with starbursts. Their cores, modest now, may yet surge if the inflow thickens. Far ahead, when the Milky Way and Andromeda knit together, both of their central black holes will sit beneath a rain of gas. A bright phase is likely before the final merge, a brief time when the new sky is lit from within. There is a literal brightness here, radiation across radio, optical, ultraviolet, and X-ray bands, and a gentler, figurative one. Destruction and creation share a table. A collision strips and rearranges. It also feeds, ignites, and reshapes. From disorder, brilliance. From a banquet in the dark, a beacon almost too bright to believe. The monsters, it turns out, are mostly sleepers. They do not hunt, they wait. Collisions bring dinner, and the whole house feels the change. No galaxy, though, lives alone. What looks like a solitary island is a bead on a thread. Large surveys sketch the same picture again and again. Filaments of galaxies and dark matter lace the universe, knotted where clusters sit, separated by vast, clean voids. The web is literal architecture. Matter flows along these strands toward intersections. Clusters assemble like cities where roots meet. Groups like our local group, home to the Milky Way, Andromeda, the Triangulum Galaxy, the Magellanic Clouds, and dozens of dwarfs ride within the bigger stream of the Virgo cluster's domain. All of it, a small strand inside the Laniakea supercluster's wide sweep. A collision in one corner is a ripple on a net that stretches for hundreds of millions of light years. In those crowded junctions, meetings multiply. A cluster is more than a gathering of galaxies. It is a bath of hot plasma, the intracluster medium glowing in X-rays and outweighing the starlight by far. Galaxies diving through it are slowed and stripped. Their gas is peeled away in tails. Star formation fades as fuel is lost. When two clusters collide, the spectacle records physics in layers. The galaxies pass largely unscathed. The hot gas slams and leaves a shock front. The dark matter halos glide through, revealed by how they bend background light. The pattern is both noisy and precise, a living map of how visible and invisible matter share the same space and play by different rules. Step back another scale, and the web's origin quiets the mind. Tiny ripples in the early universe, minute differences in density etched into the cosmic microwave background, grew under gravity's slow insistence. Slightly denser patches pulled in more matter. Filaments spun out from those seeds. Voids emptied. Over billions of years, the map sharpened into the lattice we now infer. Collisions are not accidents. They're the natural consequence of living on a web that channels mass toward nodes. The pattern is serene, even when the local scene looks loud. The same web that ties giants together also makes room for smaller stories. Big galaxies carry flocks of dwarfs, fragile and dark matter rich, trailing like a loose collar of pearls. Gravity, patient and unromantic, tugs them apart, star by star, cloud by cloud. Cannibalism is common. A large spiral eats light meals, often stirring a companion's stars into the halo, stealing its gas to paint new clusters along a spiral arm, leaving behind faint streams that arc like graffiti around the host. The Milky Way's outskirts are full of such signatures. The tidal tail of the Sagittarius dwarf, the ripples and shells traced by other long-digested companions, the Magellanic Stream swept off the clouds as they fall toward us. Far from scandal, this snacking is how big galaxies keep growing when feasts are rare. Inside the city limits, feedback from starbursts and AGN keeps the budget honest. If a merger pours gas to the center and sets off a blaze of birth, supernovae blow winds that heat and scatter what remains. If the black hole eats greedily, its light and jets can expel or rearrange the fuel supply. The result is a self-regulating ecosystem. Too much growth triggers mechanisms that make growth harder. Too little feeding leaves reservoirs intact for the next chance encounter. Over long spans, the cycle pushes galaxies toward a balance. Periods of activity, periods of rest, a long aging that ends in smooth, red light. Even the exceptions teach. Dual AGN show us how common synchronized feeding can be, how quickly or slowly pairs settle, how gas finds the last steps inward. Offset nuclei, where one black hole still glows, while the other dims, hint at timing and asymmetry. Different fuel lines, different local weather, the same global law. Where jets spear the intergalactic medium, we see lobes inflate and carve cavities in cluster gas. Those cavities rise like balloons, stirring and heating the medium so that it does not cool too quickly into runaway starbirth. A single engine, turned on by a merger, can change the thermodynamics of a space millions of light years wide. The early universe amplifies every theme. Gas was plentiful, halos were smaller, orbits were short, mergers were frequent, quasars were common, because the pantry was full and the invitations constant. Black holes leapt up the mass ladder in a few 100 million years, helped by torrents of inflow and, sometimes, by joining with other holes. The web's filaments were closer together, the traffic heavier, the cities rowdier. The light we see from that era is as much weather report as postcard. Closer to home, smaller but no less telling dramas repeat. A dwarf plunges through a spiral's disk and triggers beads of starbirth along its path. Two modest spirals tug and raise. A bridge so delicate it looks like breath, then swap some stars and part. A lenticular galaxy, stripped of gas by a cluster's hot wind, glows with the warm light of age, its new births quenched not by violence, but by the medium it swims through. Each scene is particular, all belong to the same grammar. The grammar returns to the center yet again. Accretion disks spin up, friction turns fall into fire, and otherwise invisible holes declare themselves. Jets, anchored by tangled magnetic fields, channel a fraction of that energy into narrow beams that keep their aim for millions of years. On scales where a human mind happily wanders, you can trace how those beams punch into cluster gas, push it aside, and leave ghostly bubbles that X-ray maps outline. Sprinkle such events across a cluster's timeline, and you help hold the gas at a warm simmer, hot enough to avoid a cooling catastrophe, cool enough to remain a reservoir for future stories. Among all these lights and flows, the stars keep their promises. Most never feel a collision as anything other than a slow change in scenery. Some become punctuation marks, supernovae, that seed the medium with metal and memory. Some cool into white dwarfs and fade like coals. Some, in rarer company, collapse into neutron stars or stellar mass black holes that may, given luck and time, find partners and add their own ripples to the universe's quiet music. The web makes the solitude of any single galaxy feel like an illusion. Even the loneliest smudge in a telescope belongs to a filament, to a sheet, to a history that began as a fluctuation and matured into a highway. Encounters are scheduled by that map, not by chance. The pattern doesn't erase individuality. It gives it context. A person can look at the night and see separation. The data say connection. Cannibalism, too, softens when you remember what it makes possible. Absorbed dwarfs pay for the halo's soft light and for starbursts along a spiral's edge. Their gas, once stripped, can be mixed into the disk and spun into worlds. Their stars, once strangers, become citizens of a broader city. Their chemical signatures, a record of a past life that astronomers can still read, ingested, not erased. Through all of it runs a theme that calms more than it alarms. Collisions trigger, black holes wake, starbursts bloom, feedback trims, halos steer, galaxies settle. Then, in quieter decades of millions of years, light accrues the dignity of age. The process isn't wasteful, it's cyclical. The universe spends energy to make structure, and spends structure to restart the flow. Even the brightest flare of an AGN is a note in a much longer song, the chorus, where a galaxy reminds itself what it is made of and what it can become. It helps, finally, to let the movie play in the mind at proper speed. A quasar turns on and off over tens of millions of years. A dual AGN takes longer still to tighten into a merger. A filament carries matter toward a node for billions of years. A dwarf is pulled thin over a handful of orbits before its stars blend into the background. A cluster's gas remembers a jet's passage for hundreds of millions of years after the core goes dim again. None of this is sudden. All of it is alive. Some clear night, if you look where Andromeda rises and think about the quiet feast to come, let the larger net come into view. The Milky Way rides a thread. Andromeda rides the same one. Both are beads sliding toward a knot. The Magellanic Clouds trail streams that already lace our halo. The local group drifts toward Virgo's gravity, and Virgo sits within Laniakea's broad embrace. Collisions here are paragraphs in a chapter of a book that the web keeps writing. Light tells the story to anyone patient enough to listen. And in that listening, the noise of violence turns into a steady, reassuring rhythm. The sound of a universe that builds by touching and brightens by falling, then rests, then begins again. Our own Milky Way wears its appetite like a faint necklace. Look into the halo, the wide, dim outskirts, and you'll find ghostly rivers of stars that don't belong to the spiral's neat lanes. These are tidal streams, long threads spun from smaller galaxies that wandered too close and were gently unspooled. They're quiet evidence that our home grew not only by making stars in peace, but also by folding neighbors into its light. One of the clearest stories is the slow undoing of the Sagittarius dwarf. Once around, modest companion circling faithfully, it has been caught by the Milky Way's pull and stretched into a tattered scarf of starlight that wraps around us. Each time that little galaxy passes through the disk, gravity plucks at it, loosening more of its stars. There are no crashes at the level of suns. Space is too spacious for that. Instead, orbits are rewritten. A star that once belonged to Sagittarius simply finds itself strolling a new path, its constellation map shifting by imperceptible degrees over eons, until one day it looks like it has always been a citizen of the Milky Way. The Sagittarius tail is not unique. The sky to the south holds the Magellanic Clouds, two irregular companions tugged by our gravity and by each other's. Their gas leaves a faint ribbon across space, the Magellanic Stream, a sign that our galaxy is already sampling the meal to come. Simulations suggest the larger cloud may, in a far future, be folded into the Milky Way outright, its stars and gas sprinkled into our outskirts like seasoning. This is how big galaxies grow, when grand feasts are rare, a steady diet of small bites. The pattern repeats across the cosmos. Giant ellipticals that sit at cluster centers are swollen by centuries of such meals, their halos etched with delicate streams, the faded signatures of galaxies long since absorbed. Andromeda, our nearest large neighbor, shows a patchwork of these remnants in its halo, evidence that it too has a storied past of quiet devouring. When Andromeda eventually embraces the Milky Way, it will bring that history with it. The combined system will carry the flavors of many kitchens. Why does this happen at all? Gravity and the dark matter halos that hold galaxies together make the rules. A large galaxy sits inside an invisible, massive cocoon, extending well beyond its visible edge. Smaller galaxies drifting through this landscape can become bound, losing energy bit by bit through countless gentle tugs. Over billions of years, their orbits shrink. Tidal forces stretch them thin. Stars peel away to form great loops and filaments, and the smaller system dissolves with hardly a sound. It's archaeology as much as astronomy. By mapping the arcs of these stellar fossils, researchers can reconstruct a galaxy's eating history and even weigh the unseen halo guiding the whole process. The word cannibalism sounds harsh, but what unfolds is more like mist being drawn into wind. No gnashing, no bright ruin, just patience. A dwarf galaxy is coaxed into long ribbons. Its stars continue to shine. Its elements enrich the place they join. The Milky Way would look different, poorer, simpler, without this slow, steady intake. Those captured stars thicken the halo, diversify the chemistry, and lace the outer regions with quiet variety. Even the atoms in our bodies may have passed through such stories, forged in ancient suns from long-vanished companions, scattered and gathered until they found themselves here. It's hard not to smile at the image of a cosmic menu. Dwarfs as appetizers, grand mergers as the main course. Sagittarius is the snack that never ends, nibbled over billions of years. Andromeda, approaching on its stately lane, is the banquet promised far ahead. Yet nothing is wasted. The smaller galaxy vanishes as a separate thing, but its lights are not extinguished. They join the choir, altering the harmony without silencing a note. The universe folds small stories into larger ones and keeps the song going. Push the clock forward and the theme becomes the future's headline. Our Milky Way is fated to meet Andromeda, and together they will settle into a rounded, luminous body, sometimes nicknamed Milkdromeda. The Triangulum Galaxy, the third brightest member of our neighborhood, may be swept into the union as well. What is now a handful of galaxies spread over a few million light-years will, in time, condense into one heavyweight wrapped in faint debris streams. The local group's family portrait becomes a single face. This isn't a special case. Groups and clusters across the universe are on similar paths. The rule is consolidation. Larger halos gather what drifts near. Smaller galaxies are folded in. Clusters tighten as their members mingle. It sounds like chaos, but the effect is order. Fewer, bigger systems, glowing steadily in a universe that prefers balance. Gravity is patient with its flock. Dark matter halos are the quiet enablers. When halos overlap, their galaxies become bound. Orbits decay, slowly, as energy is traded with stars and gas and tidal fields. Left to the long now, the end state is often the same. Immense ellipticals that wear the light of many histories. The spiral-rich panorama we enjoy today is a mid-movie frame. In the deep future, smooth giants may dominate the scene, glowing with the accumulated calm of countless mergers, their delicate arms long since blended into a soft, even shine. Through it all, the pace stays soothing. Streams take hundreds of millions of years to draw themselves out thin. Dwarfs take many orbits to unravel. A group needs billions of years to finish its consolidation. No single lifetime spans even a gesture of this slow choreography. Yet the results are all around us. Arcs of stars tracing old paths, chemical signatures whispering of former homes, halos holding their memories in the language of orbits. So the Milky Way's appetite is not a scandal, it's a biography. Our galaxy grew by making its own stars and by welcoming others. The evidence hangs in the dark like silk, faint and persistent, threading the sky with the roots of former companions. One day, when Andromeda fills the night, we'll be adding another chapter to that story. Until then, the halo's rivers keep flowing, soft proof that the universe builds by gathering, that even a snack can be an act of creation, and that light, once made, tends to find a way to keep shining sometimes in a new address, always in the same vast home. The future keeps expanding under our feet. Space itself stretches dark energy leaning gently on the fabric of the cosmos, and distant galaxies ride that current away. Over long spans, only those already bound together by gravity will stay in reach. Everything else will slip past the horizon where recession outpaces any possible signal, not because it breaks the speed limit, but because the road itself lengthens between all points. In that far weather, Milkdromeda and its nearby companions are a rare last cluster of lights that won't drift out of sight. The rest of the sky will thin until the familiar crowd of spirals, dwarfs, and irregulars becomes a memory kept in old starlight. Imagine eyes, born into that deep future, trillions of years from now, looking up from some quiet world. Overhead, one colossal city of stars home, and almost nothing beyond it. The web we see today, braided with filaments and knots, will have receded beyond any telescope's reach. Those distant galaxies will still exist, still shine, still evolve. They will simply be elsewhere, in a place that stretches away faster than messages can return. It's a vision that carries both splendor and a soft ache, a last grand union close by, and curtains drawing across the wider stage. Inside the islands that remain, the music continues for a while. Collisions and close passes add fuel to central engines. Gas clouds meet and collapse. Starbursts light red and pink through dusty veils. Some cores flare into quasar brightness, and galaxies glow as if making up for the thinning dark. But every pantry is finite. Gas is used or warmed and blown away. Reservoirs shrink. Star formation slows, then pauses, then ends. The large, round systems, left by mergers, settle into long, measured light. Trillions of years pass, and the brightest actors have already bowed. Massive blue stars have lived and ended. Middleweights have grown, exhaled shells, and cooled into embers. Red dwarfs, careful spenders of fuel, hold the stage, burning with patience that shames our calendars. They tint the galaxy with a soft, ruddy hush, and can endure for 1 trillion years or more. Yet even their thrift has limits. When at last they fade, what remains are the quiet citizens, white dwarfs, neutron stars, black holes tracing orbits in a galaxy that looks less like a lighthouse and more like an archive. Collisions in that era are different stories. No fireworks, little gas, just populations mixing like libraries merged into one hall. If two remnants meet, they join with hardly a ripple for anyone far away. And farther down the road, even the anchors yield. Black holes, which feel so permanent now, slowly radiate away by mechanisms that are subtle and slow. Hawking's whisper until they too are gone. What's left is not an abrupt nothing, but a thin, even quiet, that spreads everywhere. Seen from here, the path to that hush runs through gatherings like ours. Milkdromeda won't end the story. It will inaugurate the long afterward. The same is true wherever small groups sit along the cosmic web. Gravity first builds, then consolidates, then rests. Collisions build the giants that endure in a dimmer age, and, in building them, spend the last great reserves of cool gas that could have kept the universe bright. Creation and completion share a handshake. There's something calming in the scale of it. No cliff, no rush, just a slow dimming, a long exhale. Each merger adds structure and spends fuel. Each star burns its portion of time and returns its elements. Each black hole feeds, rests, and finally gives back its hoarded energy to the dark. The legacy remains in shapes and orbits and chemistry, in the way a galaxy holds its light and in the quiet clocks ticking inside every remnant. From the near present, we watch collisions as dramas. Arms twist, bridges glow, cores awaken. But widen the frame to include eternity, and they look like the most natural thing in the world. The way the universe sculpts itself from youth into maturity and then into elderhood. Galaxies are dancers and diners. Yes, also builders. They raise the monuments that survive the night. This is why these meetings matter so much. They are not a footnote in a thick textbook. They are the architecture plans, the filaments that thread the sky, the clusters like pearls along them, the spirals that spin, and the ellipticals that glow. Each owes a measure of its existence to encounters. When two galaxies approach, their invisible halos of dark matter tug long before the starlight touches. That gravitational handshake stretches disks, throws out tidal tails that draw luminous arcs against black, funnels gas inward to wake central engines, and squeezes clouds into nests of new suns. Without those nudges and squeezes, the universe would be sparser, dimmer, less generous with worlds. Collisions also answer questions that numbers alone can't make vivid. Why do some galaxies end up smooth and red while others keep their lacework arms? How do black holes grow in step with the bulges around them? Where does dark matter sit while everything bright is being flung and folded? Each merger is a natural experiment. one we can watch at many stages scattered across space and time. The outcomes: tidal tails, quenched cores, starburst beads, dual, and then single active nuclei, are data written in the neatest handwriting the universe owns: starlight. And then there's the part that doesn't need equations to persuade. Photographs from orbiting telescopes show embraces caught mid-step, streamers of stars curling like smoke, dust lanes tracing calligraphy, cores shining like lanterns pulled a little too close. The pictures don't look like violence, they look like intention, like a painter learning what a new brush can do. It's easy to forget that most stars glide through these meetings without a scratch, that orbits are what change, while the furnaces within keep their quiet work. Renewal, not ruin, is the usual headline. Chaos is only the scaffolding. A galaxy can be stretched, veiled, folded, and it remains itself in a larger sense. Its stars continue around whatever center the math fashions. Its gas, if it has any, finds pressure and calm, and makes new starlight. Out of collision comes continuation. This is the universe practicing endurance, adapting shape, keeping meaning. Patience is the art that makes it possible. These dances last hundreds of millions to billions of years. A human life is a snapshot, a single frame of a very long film. We catch a train of stars mid-arc, a knot of blue newborns in a torn arm, a core just beginning to brighten, and we call the picture complete. The cosmos smiles and keeps playing the whole movement. When we try on its timescales, the events stop being crashes and start being seasons. That patience makes the story feel like comfort rather than warning. Even the largest transformations happen as a kind of careful handwriting. Lines drawn, erased, redrawn more smoothly. The universe is not in a hurry. It holds a shape until it's time for another. We belong to that way of things. The Milky Way's appointment with Andromeda is not a disaster scheduled. It's a step in a long choreography we were born into. Our home won't end so much as move on, finding a larger room with familiar furniture arranged differently. The larger fabric matters, too. No galaxy exists alone, even when it looks isolated. Everything sits on the same loom. Clusters, filaments, and voids, woven together by gravity, from tiny ripples left in the first light. Collisions are the threads that pull the weave tighter. When we watch two galaxies billions of light years away, we watch the same process that has drafted our neighborhood's future. The lesson rhymes at every scale. If there's a moral wrapped in all this light, it's that change carries seeds. Starbursts bloom where disks are torn. Jets carve cavities that keep cluster gas from cooling too quickly. Dark matter's unseen hand steadies the arc so that what's flung returns. Even endings refuse to be wasteful. A supernova leaves iron for blood and silicon for rock. A dwarf galaxy leaves streams that map a halo. A merger leaves a galaxy that glows longer and steadier than either parent alone. The cosmos is not careless. It is thrifty and, in its thrift, generous. On human time, there's nothing to fear here. The distances are so large and the tempos so slow that all of this remains a lullaby, not a siren. As metaphor, though, the story reaches farther. It suggests that upheaval is often how shape finds itself again. That endurance is not the refusal to change, but the willingness to become. Galaxies demonstrate this without speeches, drifting through their lessons with a grace that only attention can see. So collisions matter in three deep ways. They are the tools with which the universe sculpts, giving galaxies their outlines and feeding the engines that write in bright ink. They are beautiful, art made from gravity, And they are reminders, gentle ones, that the way forward is often through transformation. When the night feels loud, the thought steadies. Everything you love in the sky was made, at least in part, by meetings and mergers. Everything you love will become something else you can love in turn. In the end, our eyes are lucky. We live in a time when the sky is crowded enough to tell the story in full. Webs and knots, spirals and ellipses, bridges and tails, quiet cores and roaring ones. We can watch galaxies collide and understand that the silence is only apparent, that beneath the hush, the longest symphony is playing, slow and sure, adding movements without losing its theme. Far ahead, the halls will grow dim, the notes will spread thin. But even there, somewhere inside a settled giant, streams of old stars will keep circling, carrying with them the history of all their encounters. That is the bridge collisions build from first light to final whisper, steady enough to walk by, even in the dark.